Doop, 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 doop. Well, it's given me the spinning wheel of death, so presumably it's streaming. I'm not, yep, it's streaming. I'm not too sure that we have a good uplink today, so let me know if you can't hear me or if things are too fragmented, and I'll see what I can do. For now, I'm going to go ahead and pop on over to Twitter and tell people that I'm streaming. Streaming, game dev, spaceships, and engine stuff. All right. Hey, Pink Hair. Welcome to the party. Today I've decided that what we're going to do is we're going to build some engines that actually function. And to do that, we're going to need to have some sort of nav system. We're going to need to have these ships understand that they want to fly somewhere and able to use the engines to do that. Be able to use the engines to do that. The nav system is largely, I'm not going to say fluff. I'm going to make it physically accurate because there's no reason not to. But detailed pinpoint piloting is not part of our goal. So we'll just take a quick look here. We do not have any ship piloting component. So that's what we're going to build. I'll go ahead and open that up in Visual Studio. I don't remember ever opening any of these, and Ship Pilot is not in this list. No, that's not it either. Why is Keywatcher still open? I don't even think Keywatcher is from this project. This is from my Avatar project. Still not used to working with Visual Studio, but it's not too bad. Okay, so what we're going to need to do for the ship pilot is we're going to have a vector, and we're going to want to move the ship onto that vector and, jet in that direction. So to reflect that, we're going to just need a couple of basic variables. We're going to need a vector3 heading, which will be where we're going. Now, we can use physics events if we want to for moving the ships around. And that's not too bad of an idea, so we're going to want to have a required component type of rigid body. So what we'll be doing is we'll be imparting some spin to the rigid body, but we don't have to do it like that if we don't want to. The other alternative is that we can bake that stuff into our piloting system and not care at all about the rigid body. Reasons for using the rigid body, mostly collision-based. Reasons for baking it in, mostly because the rigid body has a whole bunch of precision stuff going on that we would probably want to just ignore. It would make a lot of sense for us to not impart rotational velocity and instead just kind of fake it. Well, we can always figure out which one's better later. For now, we're going to go ahead and actually fake it. So we're going to have a no, I changed my mind. We're going to use the rigid body. Trying to think in my head as to which solution is better, and they're both pretty crap. All right, so what we're going to need to do is take the heading and find our vector based on, our delta, which direction we want to try and spin and all that jazz. We also can try and do a couple of things like have arbitrary ups and stuff like that. But I think we're going to go ahead and just assume that every ship is going to use the universe up for its up. Yeah. So what we're going to want to do here is find the delta, the rotation that we're going to need to use in order to get from where we currently are to our new heading. The easiest way to do that is to find our current heading, which is attached to the transform, like so. And then what we can do is use current heading dot, I'm not sure if this is in vector or in quaternion. Oh, it's in quaternion. So we can use quaternion rot equals quaternion dot from to rotation, current heading, new heading. Now that gives us a quaternion. Ideally, this quaternion will be optimized for the least amount of spin. The problem is that it's not going to respect our up direction and a couple of other details. Another option is to fake the quaternion heading by creating two quaternions based on our headings and forcing the up value to be precise the whole time, which we may do if we need to, but in the end it'll still be a quaternion that comes out of the far side, so using a quaternion now won't hurt us at all. And we'll just log that. Alright, so we're going to want to stick that on our ship. Here's our ship. P is for pilot. Nah. Why can't I drop it on? That's weird. What the heck's going on? That was weird. Why wouldn't it let me drop it? But it would. I don't understand. Oh, maybe it's because it's adding a rigid body and it got confused by the need to add two things. I bet that's it. Obviously, we're not going to be using gravity, so that should be fine. We can set the mass up ourselves later if we would like, but it should work out like so. We can also set it up as kinematic, which we'll do for now, and that'll be making our job a little bit easier. Currently, our heading is 0, 0, 0. We're going to go ahead and give ourselves a heading of 0, 0, 1. Just so that we can handle this sort of situation with some actual direction. We're not just parked. And that means that whatever ship we build will attempt to go in that direction. When we hit play, you can see we don't actually have a ship, but logically the ship exists, and it's telling us that we need to rotate. Not at all. And that's exactly right. Now, if we were to change this to x-axis, like so, we should get a different report. Yep, see how it says now we have to rotate? So that is the idea. We're going to get some rotational stuff going on, and we're going to understand how to rotate on each of those axes given our maneuvering jets. And we're going to do exactly that. So the only issue now is hooking the engines up to that. We're going to focus on maneuvering jets at the moment. The main engines will fire up when you're pointed the right direction, or when you're going exactly the wrong direction and want to decelerate. But for now, what we really need to do is get the maneuvering jets functioning, because the maneuvering jets are really the most complicated thing we have to program. So here are our maneuvering jets. And we are no longer using these visuals here. So I might delete them en masse later on. Probably not on camera, though. I'll want to make a... I haven't checked it into source control recently, so not going to make any major changes about that. And I also want to spell maneuvering jet and mix-in correctly. It helps if you don't misspell things. If you do misspell things, you are in trouble. There we go. So this mix-in is just another one of our ship mix-ins. But this one controls our maneuvering. And we're going to want to set it up with a bunch of details. Like we're going to have a rotating cuff, and we're going to have an ascension unit. I don't know what to call them. A rotator and an ascender. I guess that's probably fine. If those have like official names that I'm not aware of, please let me know so that I can figure out what they're supposed to be, but I don't think they do. So what we're going to do is we're going to have the ability for these maneuvering jets to try and point in a given direction. But in order to have that ability, we're going to need to know how flexible the rotator and the ascension cuff are. So for that end, we're going to assume that the rotator is always 360, but the ascension unit may be varied. So we're going to make a min and a max. Min ascent equals 0, and public float max ascent equals 90. Let's see. After that, what we're going to want to do is have some method of correctly setting our current setup. Now, one of the things that we're going to run into in the long run is that we may end up having multiple rotators and ascenders due to the way that level of detail stuff is calculated. Well, we'll deal with that when we get to it. For now, we'll go ahead and assume there's only one. And we're going to override the custom update, which tells us how many hours have passed. So we're going to need to know the speed at which we rotate and ascend. So public float rotate degrees per hour. And we can just go ahead and make this a big number by default, like 1,000. Public float ascend degrees per hour. And again, just make it nice and big. And for later on, when we're getting into capital ships, we may end up with maneuvering jets that actually take like an hour to move just a couple of degrees. So that'll be fun. So we're going to want to know which direction we're trying to point, and we do not currently have a heading attached to our Mixon jet. But we do know that we have a pilot somewhere above us. Our ship should have a pilot. We just don't have anything set for it, so let's go ahead and set that up. Protected pilot as a ship pilot. It's not showing up in our list for some reason. Protected ship pilot. Oh, now it is. Okay. So this is going to have an underscore. And this is going to have some brackets. So get if pilot equals null, then pilot equals get component in parent ship pilot. And there are other ways to do that. This is not a very fast way to do it, but it's something that doesn't get repeated a lot. It'll only happen when you first boot up any given ship. So I'm not too concerned about the slowdown. Get component as parent in parent is substantially cheaper than get component in children. So I'm not too worried about it. Return pilot. There we go. Oh, there's an underscore. I know I didn't detect ship pilot because I'm an idiot. Ah ha 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 ha. Okay. So we can now grab the pilot without worrying about whether or not it has been correctly set up. And that will allow us to get the current heading. So vector3 heading equals pilot.heading. Now that's the direction that we're trying to get the ship to point. Whether or not that's the direction we want to face has almost nothing to do with that, but for the moment, we're going to go ahead and assume that's the direction we want to point, just so that we can get a feel for whether or not these engines correctly orient themselves. For the sake of not going stir crazy later, we're going to go ahead and have a protected vector3 ship heading to jet heading converter. Quaternion delta. So let's call this ship maneuver to jet heading. No, we're getting too far ahead of ourselves. For now, we'll just leave it as a vector3 heading. Later on, we're going to make this a quaternion, and then we're going to turn it into a heading. But for now, we're going to go ahead and just assume that whatever direction we're trying to go is the direction we want our engines to point. It doesn't make any sense, but it will allow us to just test and make sure that all of this stuff works. So because of that, what we're going to want to do is understand which direction our engine is currently pointed and what its up axis is, because that will determine which axis we're going to rotate around and a couple of other details. For now, let's go ahead and make it work. Let's go ahead and see if it works by saying MMJ is firing. And that way we'll just be able to tell whether or not it exists. So we do not currently have the mix-in maneuvering jet attached to any of our options. We're going to go ahead and drop in some maneuvering jets. Where's the maneuvering jets? There it is. So here's a maneuvering jet, and we don't have that mix-in set up. We have a different mix-in attached. So we're going to go ahead and stick on our maneuvering jet. Huh. For some reason, I've lost the ability to drop it into the sidebar. That's very strange. And we're going to just drop in the... that's not the Ascension, is it? These are mislabeled. Humph. Well, I guess it doesn't matter. We're going to go ahead and rename this. There we go. And that should work to create us a maneuvering jet. So we're going to go ahead and apply that change like so. And delete the maneuvering jet, and then we're going to just go ahead and create a ship that has those maneuvering jets and see whether or not they fire. Or if they say that they're firing, they're not actually going to fire. So here is our maneuvering jet that we just edited, and we can just place it however we want. And we'll just take a quick look at the console, and it says that the maneuvering jets are firing, so they are doing their job. They've probably been doing their job since before they actually got attached to the ship. No, because the ship should be passing the custom update. Yeah, that should be fine. Now, one problem with these maneuvering jets is that they don't appear to be correctly picking up when we click on them. I wonder whether or not that's some... it looks like I might have broken it. This isn't a problem in the release, is it? I didn't break the release without realizing it, because I'd feel really frigging dumb if I did that. It says that it's not a ship component. Oh, I just added a rigid body to the frigging ship, and it's collecting all the colliders. God damn it! I guess we can't use a rigid body after all. Rigid bodies collect all of the colliders beneath them, and all of the colliders automatically get applied to the master rigid body. Now, this is really nice if you're trying to do something with a complex array of colliders, but it's a real pain in the ass if you don't want to do that. So we're going to have to do this without a rigid body. And that means that we're going to have to do a lot of the calculations on our own. You are lying to me. There we go. All right, I don't think we need that anymore. So we're going to pop this open and put down the maneuvering jets. So you can see that the maneuvering jets currently aren't firing because they're not part of a ship, and the parts don't update on the normal Unity update schedule. They update based on the ship's update. So drop it in and now they're updating. And if we pick these up again, boom, they stop updating. See how there's no more increasing notes? But we put them back down, boom. See? So that is a great way to automatically control it, but one thing I can't help but notice, these are not pointed the right way. It looks like when I made these jets, I, for some reason, put the jet head on the x-axis. It needs to be on the z-axis, or it will fire sideways. So we drop this back into the game world and take a closer look, and you can see this whole thing is kind of askew. Its up is backwards. Wow. This jet is a total mess. Almost everything about this jet is backwards. Is this screwed up in the... it seems like it's probably screwed up in our... yeah, I'm going to go ahead and try and fix this inside of our... models set, because if it's set up wrong here in the modeling kit, it needs to be fixed here in the modeling kit. For now, these can be moved away. We don't need them. Whoop. Where is our engine? We don't need you either. There it is. Look at that. What idiot made that? Jesus. Fucking idiot. Yoink. So the correct axis for everything we're doing is that one. And this one that you can't see should be the up. So what we've got now is a case of being rotated around completely the wrong axis. So we'll just go ahead and select all of these. We'll tell it to rotate around the 3D cursor, and then we'll do exactly that. Like so. And then what we're going to do is grab this guy, rotate it around the z-axis, like so. It looks like this also needs to be rotated around the z-axis, like so. And then we'll just grab all of those and hit Control-A, rotation. Oh, it's got some mirroring, doesn't it? All right, so we're going to have to apply those mirrors. There we are. Now everything's pointed the correct way. We hit save and we go back into our digital world here. And this should flip over and point the correct direction. This file takes a while. There we go. Well, sort of. Right, so let's go ahead and fix this up. So the maneuvering jet, boom. I don't know if you noticed, but when we were actually using the maneuvering jet, it was pointing in all sorts of weird directions because it wasn't set up along the proper angle. And that is fine. That's sort of what I expected. But what we want to do is make it so that this just works. Now, if we were to re-import the maneuvering jet from the Blender file completely, it would be in the correct location, or the head would be mounted correctly. But because this object has offsets built into it, when we changed it, it didn't get overridden with the Blender defaults, and we had to manually move shit around. But that should be fine. As things go, that wasn't too painful of a fix, and this now should work. Yeah. So we're going to go ahead and apply that change. We'll just delete the maneuvering jet so it's not in our way. When we put the maneuvering jet in now, not only will it do all the things it did before, but it will point correctly. You can see how now both maneuvering jets are pointed down the z-axis. And if I rotate them, they correctly rotate so that they're pointed correctly across the various axes. They're no longer pointed willy-nilly in every possible direction. Hurrah! Now what we need to do is set them up so that they actually rotate correctly, and that is a little bit more of a pain in the butt. The quaternion that we're getting here is probably in world coordinates rather than in local coordinates. What we need is a quaternion that's relative to our local coordinates. We're going to assume that that's not it. This is it. Why is it? Whatever. We're going to assume that this heading is going to be in world coordinates, and we're going to need to convert it into a local quaternion for that purpose. So quaternion rot equals quaternion dot from to rotation, and we're not going to be passing it our heading. We're going to be passing it our ascender's heading, our head. And what we're going to try and do is rotate along axes that we are restricting the axes that we're going to be rotating on. So let's go ahead and just currently set the rotation flat out and see what happens. Oh, well, no, I guess it does make more sense to lerp to it. So the quaternion that we get has a couple of angles in it. W, X, Y, and Z. These angles are not technically going to be in our personal space. These are going to be based in the world space. So we're coming up with the world coordinates for we're moving our head over to a new location via world coordinates. That's kind of useless. We could just spin the head around so that it points, but you'd find that the rest of the ship wouldn't follow along correctly. The rest of the object wouldn't follow along correctly. We could also do some tricks where we flatten it, and then we use the rotator, and then we use the ascender. That would also be possible, but I think the easiest option is to just convert the quaternion into local space. So transform dot, do we have a quaternion transform here? World to local matrix. I actually don't know whether this will work if I just multiply it. This doesn't seem right. Yeah, it's not. I haven't had to do this in a really long time, so I don't remember off the top of my head. We could do it in the other direction and transform our heading into local coordinates. So let's try that. Heading equals transform dot transform direction heading. Ah, that's actually backwards. Inverse transform direction heading. Now the heading is in our local space. And instead of converting from our ascender's forward axis, we're going to want to convert from our ascender's Z. And do I want to do it this way? I'm trying to think of the best way to do it. In the prototype, what I did was I flattened the heading down and then painstakingly worked out the best angles. Normally I don't do quaternion stuff on screen because it's a lot of like, how do you do this in Unity without screwing it up? And there doesn't appear to be an easy way for me to convert a quaternion into local space. Well, for now, why don't we go ahead and set up our local heading just to see it happen. Ascender dot look at, and then we can just say ascender dot location plus the header. Oh, that is oh, we could load this ship, I guess, but really all we need is one lonely little maneuvering jet. See? So what we have here is a situation where the header decided it was going to look in a direction, and it did something unexpected. It pointed itself straight down because the z-axis is different in the universe. I forgot. So if we were to look at the maneuvering jet here, if we change the heading from z of 1 to y of 1, this is the sort of thing we were looking for. And if we move it around, you can see that it flips. It awkwardly spins. And this is the problem with using the look at command. Now you can set an up, and that will partially fix it. But that's the reason why we want this to be a, so the world up will just make it our transform.up. But that still won't fix it because it's the job of the rotator cuff to point this head in the correct direction. So if we were to turn it around, boom. Why is our, Oh, that's right. I forgot. I didn't fix it. There we are. So, if we were to bring this around, you can see that it still flips over. So, in order to not do that, we need to have this rotator cuff bring it around. So first off, let's change this. If we apply this to the rotator cuff, I think that the transform up might actually be wrong. I have to look into that a little bit more in a minute. So, in theory, this shouldn't be doing what it's doing because... Oh, well... Is it oriented on the z-axis incorrectly? Do we have the z-axis wrong? We have the z-axis wrong, don't we? We do. God damn it. I do have to reopen that file I just closed. Sorry about all this. I was mistaken. I forgot how this thing converts axes, and I ended up converting the axes wrong. I think that this is correct. Maybe that's why it was in this sort of position before. So it looks like I might have done it right originally and then broken it and spent half an hour live on camera in front of all two of you, screwing it up. I know that that's exactly what you come here for, so I'm glad I could please. So we're gonna need to pull out the maneuvering jet again and fix it up, which largely consists of bringing this guy back into the correct position. Here. All right, let's see if this works. Put in some maneuvering jets again. Boom. All right. So, when we tell it to look at the y-axis, it looks down. Correct. Okay. So that's why I was looking at the z-axis before, because the y-axis isn't what we care about. Hooray! And you can see that now we've got it set up correctly. It works for certain values of work. As long as it's only on the x-z axis, the ascender can handle, or the rotating cuff can handle everything. It's when we need to start to look at the y-axis that we need to start to split things up. So in the old version, what I used to do was I would flatten it. I would cut the y component out. And I think that might still be the best option now that I'm thinking about it, because we do not have... In the previous version, I had 2 axes of limited rotation, and in this version, I'm assuming that the rotator cuff can rotate infinitely. So it should be fine to just rotate it. Yeah, I'm thinking we're fine. So what we're going to want to do is we're going to want to create a rotator heading. So vector3 rotator heading equals rotator dot inverse transform direction heading. And we're going to want to set rotator heading dot y to 0. And then we're going to use this rotator heading. But we're going to want to convert that back out. Rotator heading equals rotator dot transform direction rotator heading. We could also do that by applying a flatten operation, but then we would have to work out a flattened plane or an exemption plane. That might be easier, actually. Let's take a look here. So if we were to do this, we could say vector3 dot exclude And then we're going to want to, actually, can I apply the exclude directly? Heading.exclude? No. Vector3.exclude. And then we're going to want to exclude the rotator up. So rotator.up from the heading, which is equivalent to what I did here, but cheaper. Why is that underlined in green? Did I project on plane? Okay. Vector3.project on plane. Heading, rotator up. Oh, they're in opposite directions. Great. That's fine. All right, let's see whether or not this works. So if we pull up our maneuvering jet, drop it into the world, we'll go ahead and drop one like this. We're going to just go ahead and duplicate that and drop it like this. There we go. So the rotator heading doesn't appear to be very accurate or correct. It doesn't seem to be updating properly. That's interesting. What's going on? The maneuvering jets have stopped working all of a sudden. I don't think they're responding to... Oh! Okay. Okay, so what we're trying to do is get them all pointed in the same direction, and it's actually working pretty well. See? I was adjusting the y-axis because I was an idiot. Let's not go into detail. But if I adjust the y-axis, only the two that don't have any y-axis, that do have a y-axis component, will bother to change direction. See? Now the question is why they didn't update immediately when I first put them in. Maybe I was hallucinating? I don't know if you were paying attention or not. You have to let me know. Oh, I know why. Because I was at y equals 1, idiot. There we are. So now what we're going to do is the exact opposite. We're going to get the normalized vector that we're trying to reach with our ascension unit. So because we know this works, we don't need this commented out stuff. And what we're going to want is vector3 ascension heading equals rotator heading equals heading minus rotator heading. And that'll give us the excluded amount. And then we can just use lookat. Yeah, we're still going to use rotator.up. All right, so now let's go ahead and see whether this works. So let's put in some maneuvering jets here. Oh no, we're vibrating violently. It looks like I have accidentally applied it to the wrong... Yep, I did. Brilliant. Okay, fine, we'll load a ship. Do any of these have? I think they have some. Yeah. Lights. This might be before I created... Oh, there they are. They're hidden away. You know what? That's too hard for me to detect at the moment. Let's go ahead and start over and just put them in so that we can test them out. Boom. All right, so now what we see here is that the heading is less than 0. While it works, even this doesn't work right. It's greater than 90 degrees. Well, it's definitely not even trying to point the same direction. I wonder what's going on here. So one of the problems is, of course, that the head is going at negative values, but a bigger problem is that it appears to be just going wrong. Yeah, look, see this? This shouldn't happen. It should only be changing one of the quaternion axes. And instead, it's doing all sorts of weird shit. So there's something wrong with our ascension code. Look at is a notoriously basic operation. So it doesn't actually... it rotates, so not basic, opaque operation. It rotates on several axes at once and tries to figure out what the shortest way to get there is. That might be what's causing us some problems, but in the end, what we should have here is the rotator heading rotates correctly, and the ascension heading just moves on, I believe, the x-axis of the quaternion. If we pull in one of these maneuvering jets and fuss with it, we should be able to tell right away. So take this rotation here, and we look at the rotation XYZ. If we do this, you can see it's just the x-axis. And this should be what it looks like. And I guess that is what it looked like for most of them. Some of the times we had some other axes involved, though. So if we want to determine what angle our x-axis needs to be in, I think we can just do some basic math. I don't think we have to use any kind of look command. We can just the angle, we can calculate the angle that we need because it's not currently using the current direction of the head, so we can just say float angle equals, and then give it the what is it going to be? Mathf dot I guess it would be a sine? I think it's a sine. That doesn't sound quite right, though. Ascender.local rotation equals new quaternion, and then we'll just go ahead and pass in the angle 0, 0, and 1. Let's take a look here. My memory of quaternions is a little bit fuzzy. Anyway, we got this guy erroring out. That's fine. He's not in a ship. Boom. And now, these are pointed the right way, I think. Oh wait, what the heck's going on here? Oh, because it's the sine, so it doesn't know whether it's below or above. So if we assume that it's going to be within the correct constraints, like say this, well, what are you doing? There's something. I guess it needs to be an A10. I don't want it to be an A10. No, that was me just doing some stupid stuff that doesn't make any sense. Well, this heading isn't in local space. This heading is in global space because we were trying to use the lookup on it. We can change it into local space. So ascension heading equals ascender dot inverse transform direction ascension heading, like so. And now that it's in local space, we can actually tell where we need to be looking. So maybe now we can use the float angle equals ascension heading. Oh, well, yeah. Ascension heading dot magnitude. We probably want to see whether or not the axis is negative or positive. Let's go ahead and just debug log it. I'm afraid that this is not my most exciting stream. I don't feel too bad about it. It's the Wednesday before Thanksgiving, and apparently nobody gives a shit. And that's fine. On doing something like this, having a big group watching would be just stupid. It wouldn't entertain anybody. So what we're trying to do now is just get a feel for whether or not the space is in the correct. Evil Luigi is complaining that his phone didn't tell him I was streaming. You didn't miss anything. So we can see that the local coordinates are -3 and 0.4, which seems correct. Let's go ahead and see whether or not those correctly change when we move it. Yeah, 0, 0, 0. Really? Interesting. And 1, -0.9. But these are both 0.1, -0.9, even though there are two of them, and they are pointing in the opposite direction. I really want to use lookat because it's super easy, but it's not working properly. I need to be able to hand it more constraints than it's willing to give me. I wish that I was better at this. Quaternion dot... Does this have any other arguments? No, it doesn't. This is something very basic, but I can't remember why or how to make it work. In case you haven't noticed, we're going to be using this function in the end. But I can't remember how to get a quaternion. Evil Luigi says, what are those icons on the side? Icons on the side? I don't know. Do I have icons on the side? Oh, are you talking about the holographic icons I put in? Those are in the new release version. You can go and download them and play with them if you'd like. I'm presuming this is what you're talking about. So, what I'm doing now is I'm using lookat as a really, really primitive way to try and get this object to orient itself correctly to a world position. The problem is that lookat can't be targeted very aggressively. So when we say ascender.lookat, rotator.position, maybe it should be ascender.position. No, rotator, that's fine. Plus ascension heading. We'll go ahead and multiply it. And then we put in an up direction, like rotator.up. Oh. In theory, it'll look in the correct direction, but the correct direction will be it won't be oriented properly. So if we bring in the maneuvering jet here, and we do this, for example, well, those are oriented correctly. They're going in the wrong direction. They're negative, but they're oriented correctly. If we were to flip it over, no, it's just doing something stupid. See, here's what I'm talking about. It doesn't understand what's going on, and it's just locking itself in at awkward 90-degree angles. I honestly don't know what we're going to do about this, because I don't remember. The way I did it before is not a very good way. If we do this and we say that we want to go z equals 1, that should be towards our center, so that should be probably that way, I imagine. Nope. Apparently it is being judged as... I can't even tell. Well, this one's obviously not doing anything. We can pull it in. Why not? So this one actually points in the correct direction. But if we do this, it no longer points in the correct direction. Now the z-axis should be this way, so all of these divots should be pointed that way, and they all are. So the rotator cuff is working, at least mostly. The problem is that our head is broken. This one is non-viable, so we're not going to bother with it. Just click like this, make it viable. So instead of properly being viable, it's actually flipped like 90 degrees the wrong direction. It's flipped and spun? That's interesting. Can we just change our own... just today, Evil Luigi had to learn for an exam, and he's busy, so he's going to play some Metro and just listen to me. Comments will be scarce. Well, you've made more comments than everyone else combined so far, so that's fine. Okay, so this is obviously just wrong. It keeps being correct, but then the rotation of the head becomes very, very silly. The rotation of the head should be 0, 0, because that would be z. See? So that's the z-axis, right? That's z plus 1 over there. That's why I did this, because it's a super easy thing to do. So I'm not sure why it's flipping around and looking in some other direction. Oh, I bet I know why. Nope, that wasn't it. So if we look at the ship, 0. So when we take y out of the equation and just leave ourselves with z, in theory that's a horizontal axis. Z shouldn't be doing anything. If we actually grab one of these maneuvering jets and we increase it on the Z plane, you should see it slide. Yeah. So it should be trying to point along this axis, and instead it's doing some really weird shit, just kind of randomly pointing. I want to see whether or not moving in that direction. So Z. Okay, so the z-axis here is correct. So there's something wrong with how we are setting this up. Debug.log ascension heading. Zero, zero, zero. So when I tell it to look at 0, 0, 0, it points straight up in the most awkward way imaginable. Is it still 0, 0, 0? No, now it's 0.50. 0.50 is, in fact, down. Huh. Why does it want to look down? Because I got a y-axis on this thing. All right, so one of the problems is that if the heading is 0, 0, 0, it panics. So we're going to go ahead and set up the quaternions now. So quaternion ascension heading equals quaternion dot identity. Or quaternion dot ascension q, we call it AQ. If ascension heading dot magnitude is greater than 0, then AQ equals quaternion dot look rotation, and then we pass it our forward, which is the ascension heading. And we can also pass it the upwards, which is going to be our ascender dot up. And then we say ascender dot rotation equals ACK. Now the ascension heading is in global space, so that should work. Let's try it out. All right, so first things first, the ascension heading obviously is trying to do the y equals 0.5 bit. We'll just go ahead and say 0. So here we say look rotation viewing vector is 0. But the magnitude is greater than 0. That's interesting. Fumbling through quaternions is so much fun, right everybody? So here we can see that the viewing angle is 0 because it's along the z plane. And if we were to rotate this, it would still be 0, but you can see that what we ended up with was a global identity quaternion rather than a local identity quaternion. Aha! Okay. So what we're going to end up doing here is translating... If I could translate quaternions into local space, I'd have a much easier time of things. I'm sure there's a way to translate a quaternion into local space. I just don't happen to know it. So this is the busted quaternion, and it's still busted. And we're getting this response here. If ascension heading dot magnitude is greater than 0, log ascension heading. 0, 0, 0. Is this like a floating point bug where ascension heading is actually like 0.000001? Yeah, great. Either way, we're still getting this problem where we're using the world identity, and what we really want to do is set it to the local identity. So what we can do is... quaternion AQ equals quaternion else ascender.rotation, except for we're going to say ascender.local rotation. I have to spell it right. So that works, but the instant we start to use any y-axis deviation here, oh, x-axis because of the plane we're on, it snaps. See how that didn't work out for us? Aha! I I figured most of it out. Okay, so the problem is that I'm trying to use a single direction. It's always going to look straight up because that's the only direction I'm allowing it to look. What I actually need to do is exclude the right axis. So here, when we say ascension heading equals heading minus rotator heading, we're actually going to do this. Project on plane rotator.right. And this means that there should always be a heading. So man, I am not very smart today, and I'm sorry if you're listening into this and being like, this guy is doing stupid math and he's not very good at it. I'm normally not quite this bad. Yay! Look at that, everybody! It's working! Watch, watch, watch. Zip. 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 Hurrah! And if we change the y-axis... Hey, not bad, huh? Ah, not bad. Look, look. It's working. But we don't have any of the limits built in yet. So what we need to do is determine whether we are past our limits or not. If we look at the rotator head here, you can see that our rotation is marked as -32 on the x axis. I believe that this is in degrees, but it's actually in radians internally. I can't remember though. Either way, our quaternion needs to be analyzed. The x-axis should be the only one which has any values, which is why I was originally trying to calculate those values out. And now that I've remembered that, duh, we need both the forward and the up, there's no reason for us to do this after all. So all of that annoying stuff was just to be able to find the angle. Because the angle is, of course, mathf.atan2, and then we're going to have the y and the x. The y is going to be the ascension heading. Well, we don't have it yet, but it's going to be the ascension heading.y and the ascension heading.z. But we have to translate this into local space. So ascender dot inverse transform direction ascension heading. Ascension heading equals ascender dot inverse transform direction, blah, 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 blah. Let's go ahead and paste that into our debug log. And we're also going to then set our quaternion's x-axis to that. So ascender dot local rotation equals quaternion, new quaternion. And then we're just going to pass it the angle, and then 0 and 0 and 1. But as I said, I think that angle might have to be translated from radians into degrees or vice versa. We will find out. Boom. Whoop! Well, that certainly didn't work right. And we can see that locally, this is -0.7, -0.7. That's interesting. Because it shouldn't be. It should be 0, 1, or 1, 0. So there's something a little screwy going on here. So string debug equals ascension heading dot to string debug.log debug plus verse. Okay, there we are. So what we would like is to know why this isn't giving us the values we want, and we're going to do that simply by looking at the debug values. Now, because we are supposed to be going at just the z-axis, our debug values should be, yeah, see, 1. For some reason, so here we see 1 versus 1. You got that correct. But then it starts to skew. So as we begin to rotate, it begins to think that it needs to move along the z-axis, along the y-axis here. But of note, this is -0.3 and 1. So this isn't maintaining magnitude here. It's not normalized. But that's okay. We don't need it to be normalized. So as the rotator cuff spins... Oh, as we move, of course our destination moves. Okay. So what we actually want to use here is the rotator cuff. Because we're trying to calculate the angle from the rotator cuff. The head will just get fixed in whatever angle we want it to get fixed in. So if we start to include an x-axis stuff, you can see that it now works fine. However, it is a little bit aggressive. No, I guess that's not. I guess that's in the correct units, because that is right. If we make this z of 0, 0, then it screws up. If it's not a normal, it really does screw up quite badly, doesn't it? Alright, so that's actually correct. And what we need to do is make sure that we don't ever end up with a negative angle. So specifically, we already know our angles here, min and max ascent. So what we're going to do is we're going to determine the angle, and then we're going to say if angle is less than min ascent, angle equals min ascent. And if angle is greater than max ascent, angle equals max ascent. To be honest, we can do this exact same thing for the rotator cuff. We do not have to use look at, but there's no reason not to use look at, so we're probably going to. I thought so. The angles are backwards. That's fine. What we're going to just do is invert them. So angle equals negative, and then we're going to say negative. There are other ways to do it. There we go. So now we're going to go ahead and put in some x, yoink, but it doesn't go down. And if we go too high, oh, it goes way over 90, doesn't it? Maybe it does need to be converted into radians, because that doesn't seem right. Yeah, that's not right. So we then say mathf dot angle to radians. There it is. Oh, time is negative angle. I forgot it was just a constant. That's fine. Alright, so now when we start to do this, we should asymptotically approach 90, but we should never reach it. Now that's too much. There's something wrong here, because this should be at almost 90 degrees, and it's like not. So this is obviously incorrect. Let's go ahead and set the max ascent to 60. 45. And then when we start to move it on the x-axis, okay, it is not listening. Negative 111 is higher than 45. So there's something screwy going on here. Let's take a look here. So we don't need this anymore. Hmm. So this is a very small angle, scientific notation angle, and that's correct. As we move the x-axis... Oh! I'm just a fucking idiot. We need to translate minascent and maxascent into degrees, radians. It wasn't... the angle wasn't needed to be... I didn't need to convert the angle into radians. I needed to convert the constraints into radians. Of course. Oh, God, what an idiot. There we go. And there we go. But that is not locking at 45 degrees. That is locking at something that's not 45 degrees. 45 is like this, right? We are stuck at 45, right? Yeah, max ascent 45. Debug.log angle times mathf.rad to degrees. Zero. Correct. That is 0. 19. That's not 19. That's not 22. Huh. This is strange. Why does it think that this is 22 degrees? Is it because I'm screwing up the W? I bet it's because I'm screwing up the W. I just kind of slapped that in. Local rotation. Yeah, I screwed up the W. So if I wanted to be at 22 degrees, I would have to be at... Can I get a degree? Quaternion dot degree to... No, but I can do angle axis or angle. Angle. Returns the angle of degrees. No, I want the opposite. I want a quaternion that represents an angle. Angle. Comma, axis, vector 3 dot forward. No, vector 3 dot... Right? Let's try it. I wonder whether this is going to be in degrees or radians. I guess we'll know right now. That's definitely not in degrees. It may actually just be backwards. So, angle times equals mathf.rad 2 degrees. That's correct. All right. So that works. Okay, that was kind of obnoxious, but in the end, we figured it out. The issue here is a lot of annoying little details that I had forgotten existed. Hurrah! But now you can see that it will instantly look at the correct spot on the horizon. It will instantly try and move to look at any place you put it. Now, what we need to do at the moment is make it so that instead of being instant, it progresses at the correct rate, hours past. But unfortunately, there are times when we are going to be paused and it's not going to move. And we're going to have to remember that. Either way, right now, we are going to adjust some of these values based on the amount of time that's passing. So this angle axis is correct, but what we actually need to do here is quaternion dot rotate towards, and then we're going to say from ascender.local rotation to quaternion angle axis, blah, 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 and max degrees delta will be our ascend degrees per hour times hours past. Easy enough, right? The only question I have is whether or not that's going to be degrees in degrees. That must be, right? So that should be okay. Up here, we're going to do the exact same thing with the ascender, except that, or with the rotator rather, except that we're going to be using a slightly different method. So quaternion, rotator dot quaternion, rotator dot rotation, equals quaternion dot rotate towards rotator dot rotation, comma, this, hello, there we are, quaternion dot look rotation, rotator heading, rotator dot up, and of course that'll be the rotator degrees times hours. There we go. All good. Okay, so now it will move based on the amount of time that's passing. Right now, right now the universe is paused. So let's go ahead and unpause our universe. All right, so now time is passing, and we're going to go ahead and see it rotate in real time. Ready? All right, we're getting somewhere. It took me an hour of dumbass mathematics mistakes, but we are currently using these correctly. We have some systems that will correctly line stuff up. The only problem I have is that it appears that we do have some bugs still left. So right now, if we were going to go for 1, 1, that would be exactly that way. So the question is why these guys are pointed wrong. The ascenders are wrong. And that might just be because I got my angles backwards. I did invert them. And I might need to not invert them. Well, let's take a look. Hold on. Stop. Now, unfortunately, I don't actually remember whether y of 1 is up or down. It's one of those details that always eludes me. But I think it's down. So this should be correct. All right. So with unrotated, when I stop When I stop inverting the angle at random, it should be fine. And when I raise y to above 0, you can see how it reacts. Neat, right? And I can include some x. Ah. So now, if I were to load up a ship, like, say, the Red Planet, those should be correctly orientated. See? 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 They're pointed the correct direction. Well, let's go ahead and make this 0, 0, 1. A negative 1. See, there's a bug. There is a bug. The rotator cuff has separated from the correct axis. That's fascinating. I wonder what causes that. Because I don't remember telling it to do that. Well, let's try loading another ship and seeing what happens. The Agrippa. So there we are. We got them in the back here. The rotator cuff is still intact, no damage. If we invert this, they should spin around like so. Ooh, beautiful, beautiful. Not a very good place to put them, but that's besides the point. Let's go ahead and spin them upwards or downwards. Let's try and spin them upwards. And then set them to 0. There we go. Now we can include the x-axis like 1, and you can see what happens. Wonderful. 0. I'm not sure what broke the... I'll have to look into that and make sure that I don't let that just boil forever. But for now, I'm thinking that this is not too bad. We've got our maneuvering jets set up so that they point in the correct direction. Now, we haven't set them up so that they actually jet, and more than that, they're pointing in a direction we specify, but that direction is not the direction they need to fire. The direction that they're pointing right now is the direction we're trying to go. So the point of maneuvering jets is that the ship is trying to turn to that heading. And it makes 0 sense for the ship to turn on that heading by firing the maneuvering jets in that direction. It would actually work in this one ship's case. But for most ships, that's not going to be what we want to do. So we're going to need to convert our overall ship orientation changes into an orientation, into a vector based on where our jets are on the ship. So that jets in the rear would point one way and jets in the front would point the opposite way to get some spin going. Now, I've done this before quite a few times. It's not too hard in some respects, but it is hard in other respects because it's a multi-dimensional change, and I have spent an hour and a half doing stupid-ass dumb mathematics that I got wrong. So you know what? I'm definitely not going to do any more math. I'm up for maybe another 10 or 15 minutes of stuff if anyone has anything they want to see. But I think you'd have to recommend something, since I am a little bit burned out from all that math, getting all that math wrong. Let's go ahead and pull up some other ships here, like the Hansi. Have you got any maneuvering jets, Mr. Hansi? No, you don't. Let's go ahead and stick some maneuvering jets on you. Oh, you do. They're up there on the top. I see them. You just don't have any on the bottom. I think you'd do well with 2 more maneuvering jets. Oh. There we go. Yeah. Let's go ahead and save that. Save ship. And let's rearrange the ship's intended vector. So that it's obvious. And then what we'll do is we will pull up our help file. I think F1 broke, but I don't know whether I broke it. I don't know which part I broke here. No, I definitely broke it. I'll have to look into that. Trying to find an angle where several maneuvering jets are visible. I guess that is one. Hey, Pink Hair, I got the maneuvering jets pointing in the right direction, and I got them to turn at a rotation rate that makes sense given the amount of time that's passing. I don't yet have them pointing in the correct direction, though. They just point in an arbitrary direction. I'm not going to do any more math today, so if you want me to do something else, you'll have to ask me to do something else. Right now, I'm just trying to line up a shot of these maneuvering jets so that I can post it on Twitter. Tweet, I made maneuvering jets point the correct direction using a rotator cuff and a ascension head. It was pretty dull. All right, well, now that you're back from dinner, Pink Hair, I'm thinking about leaving. If you have anything you want of me at the last minute here, I'm glad to answer any questions or whatever. But, as it turns out, screwing up Quaternions for an hour straight burns my brain out. Good news! Long vacation. I'm not going to spend too much of it working on this, but maybe, 8 or 10 hours. It'll be nice. I'll definitely be back on Saturday to do some more work. I don't know whether I'll be streaming longer than usual because it's quite a bit of talking and my voice does burn out. But actually, I can guarantee I won't be streaming more than usual because I've got another 6 or 7 hours of Life is Strange to record. And I'll be doing that probably tomorrow. So my voice won't be up for more than 2 hours or 3 hours at most of streaming on Saturday, but I'll be working on it off-screen a little bit. I don't know how much off-screen work I want to do, though, because a lot of this stuff is stuff that I think you guys might like seeing. For example, particle effects and that sort of stuff. I'm going to be putting in actual stuff. Controls that allow you to move the ship around. The heading axis that you might have played around with the piloting prototype. All of that stuff is coming, and I don't think I want to do it off screen. I think I want you guys to see most of it. Pink Hair does have a question. He doesn't type very fast, but he does have a question. Maybe he does type fast, and it's like really, really long. Twitter is telling me that I can trim clips out of my live stream. I'm sure that everyone would like to see a clip of my engines going weep, whoop. Wah, wee, wah, wee. How exciting. It's very organic. That feels really good. Yeah, I like that. I like that a lot. Okay, so his friend is using 3D objects inside a UI. Presumably you mean a canvas element. Pink Hair says when they're instantiating, they are being instantiated in the wrong direction. Yep. So, the real issue with using UI elements and game objects in the same, at the same time is that you're combining traditional transforms and and the newer rect transforms. The good news is it's actually not too hard. When she's setting the parent, she needs to say true. So I'll go ahead and type into the chat what I'm talking about. For example, we would say blah blah equals instantiate blah prefab. And then she would say blah dot transform dot set parent UI target comma true. If she specifies true as a second argument, and she's probably leaving it empty right now, then the rotation will get reset. If she specifies false or just leaves a second argument gone, then the rotation will be set to whatever it is on the prefab, meaning that it'll continuously keep that same rotation. The same is true for the transform offsets, and in some ways the scaling. Scaling is handled a little bit awkwardly in that particular situation. But in general, you should rely on rect transforms to set your positions. And the problem is that in the end, screen coordinates and 3D objects... Okay. So good, you have it wrong. Because I was about to get into a really complicated spiel about why that's not such a great idea. Apparently I have it wrong. The 3D object is part of a prefab inside of a UI element which is being instantiated. When instantiating the prefab, the 3D object is coming in rotated incorrectly. Okay, so the reason that that is normally the case, generally speaking, using 3D objects inside of a rect transform is a bad idea unless your UI object is in world coordinates. So this is an impromptu lesson on world coordinates. This canvas object here has the option to be in screen space, overlay, screen space, camera, or world space. If it's in either version of screen space, then the prefab, the 3D object inside of the screen space prefab is going to be all screwed up. And that's because the visuals for these kinds of UI elements are, this is what it looks like, right? And it rotates arbitrarily to try and scale and fit the screen. And if you're in camera mode especially, it'll rotate itself quite arbitrarily. So it's, generally speaking, using 3D objects inside of... You know what? Maybe it is possible. I'm talking a lot, but I'm thinking through it slower than the mouth is moving. I'd have to know exactly how the rotation is coming out bad. You know what? We could just go ahead and try it on a different project. Come on, Unity. There we go. So here is my avatar project where I'm testing out various ways of keeping the avatar intact. It's very simple, and it doesn't matter if it gets destroyed, so let's go ahead and try it out. Create a UI, canvas. Is she instantiating a canvas or a rect transform? If she's instantiating a canvas, it should work. If she's only instantiating a UI element inside of a canvas, that would probably be the problem. But we're going to go ahead and give it a shot here. So I've just created this image in the middle, and we're going to take one of these let's go ahead and use one of these test blend characters, just because these are fairly easy for us to tell which direction they're pointing. And we're going to scale it way up. 100 is fine. With the idea that it's going to be standing on top of our little box. Now we're going to hit play and see whether this works. Oh, of course! Duh! I'm an idiot. Okay, so the obvious... I think it's an image with a 3D object as a child. So the biggest reason why that's not going to work is blatantly obvious once I actually think about it a little bit and stop being a total idiot. They're not rendered on the same pipeline. Sorry, it took me so long to catch up with this. My brain is still fried. So look at this, okay? I've got this UI object, the canvas, and then I've got this 3D object inside of it, and I've got this image that it's standing on top of. And you might think that if I hit play, it's going to show it like this, but that's not the case at all. We're not going to be able to see the character in the slightest. And the reason for that is because the camera that we're using is down here, and it's rendering this spot in space. Whereas the character that I put, it's way the hell up here. Way, way off screen, right? Now, if it happens that your camera is pointing at just the right location to perfectly frame your UI, then yeah, that might work. But that's really finicky, and I've never heard of anyone doing that. One of the other things you might try is changing the layer to UI, but I don't think it's not going to help because the pipeline is completely different. Yeah, so this does work if your canvas is set to world space. So if it's set to world space, then we can't see anything because it's too big. But if we move the camera, that's the event system. If we move the camera so that it can actually catch this, yup. Now that the canvas is in world space, it gets rendered in the same pipeline as the 3D object. So, yeah. So if she wants to combine 3D objects and UI elements, she's going to have to use a world space UI element, or she's going to have to use a render texture and a separate camera, and those start to get real expensive, which is why I'm not using them for my own thumbnails. So that is the core of the problem. The pipelines are completely separate. If you put them into the same pipeline, you can do it, but by default they are in completely separate pipelines. Yeah, if it's in camera space, I don't use camera space very often. It could be that it would be a little bit different. So my guess is that the location is only fine because she just happens to be in a specific location with her camera. The two are not intended to interact at all. So the thing I would recommend to her is to not do it like that. Anyway, if you're wondering, yes, I got the avatar working fine. Now all I'll have to do is integrate it into the game and spend, 9 or 10 hours doing that. All right, so I've answered that question, aside from faffing about with random mumblings for about 10 minutes. If you have another question or want more details, you can let me know. Starting to get a headache from talking too much. So I'm going to go ahead and stop now, but I'll pay attention to the chat for a while longer.